Okay, for this lesson, we're going to be talking about bulk properties. First of all, we're going to talk about what is brittle. So brittle means that it is easily fractured or broken. However, what do we mean by this? So when you apply a strong external force, now it could be strong or weak. So let's draw a graph of what we mean. If we have pressure here and we have percentage length change, you will get a straight line, but then it breaks after that point. So here is when it breaks. So it does obey Hooke's law. It does not go through plastic deformation. Okay, so brittle means it is easily fractured or broken. If you apply a strong or even a weak external force, it will break. So, and the graph, if you have a pressure against percentage length change, you will get a straight line, but it breaks after a certain force or a certain pressure, and that is when it breaks. So it does obey Hooke's law, but there's no plastic deformation. All right, and what about what is malleable? So malleable is something that you can change shape without cracking or breaking. So it can change shape or structure without cracking or breaking. Now, if you were to compare a malleable structure compared to a brittle structure, it can go through plastic deformation. So here, plastic deformation could be in this part here. So here is the limit of proportionality. Here could be the elastic limit. Now, from this region here, it doesn't have to obey Hooke's law. What it does mean is that because it is not a straight line, even if you were to go in this region, it might be able to go back to its original length. So after the limit of proportionality, where that is the end of that straight line, limit means the end of that straight line. If you go beyond that point, you still might be able to go back to its original length. But if you go past the elastic limit, it will not go back to its original length. Now for this ductile material, instead of breaking here, if you think about the atoms, they can slide over each other. So for a metallic bond, because there are free electrons, if you were to apply a force here, so there's the force, they can slide Okay, so each are in layers, and if you were to apply a force that way, each layer can slide over the other. Now, because there are free electrons, the overall bonds aren't broken. Because of the free electrons, overall no bonds are broken. Now, if you have a giant covalent structure, then the bonds can be broken at once. So if you were to apply a force at this giant covalent structure, the bonds can be broken at once. If there is enough force. Similarly for ionic compounds as well. So they can also be broken at once. And they are usually brittle. So the ionic compounds are usually brittle. All right, so what do we mean by bulk properties? Okay, so for example, if you just have one atom compared to many, so it would not conduct electricity. You can say that it isn't brittle. It doesn't make sense to talk about one atom being brittle because brittle means easily broken. So you've got to have a large number of these in order for brittle to make sense. So when we say bulk properties, we mean by many atoms joined together, so many atoms or even molecules, as opposed to a single molecule. So bulk meaning the properties of many of them or many molecules. And they both have different properties. And what about simple molecular structures or even polymers? So simple molecular structures have a weak intermolecular force between them, and these forces are easily broken. However, if they were in a solid state and they arrange in a lattice, they could be brittle. So simple molecular, so simple molecular or polymers, they have a weak intermolecular force. And if they were to become a solid, so if you were to cool them down, for example, and if they became a solid, then they would be brittle because they would still have a weak intermolecular force. What if they are not arranged in a lattice? So if they're not in a lattice, what they could be is that they could be flexible, they could be waxy. So if it's not in a lattice, meaning it is not rigid, then it will be flexible or even waxy. Right, let's talk about conducting electricity. So in order for it to conduct electricity, they have to be free electrons, right? They have to be freely moving. So if you have like a salt, for example, where salt is a solid ionic, and you have let's just say that's positive, minus, positive, minus, minus, positive, minus, positive, right? So if it was a solid, it will be held rigid, and they would not conduct electricity. So why would they not conduct electricity? Because it's held rigid and it is not freely moving. So there's no free charges for a solid. So in order for electricity to happen, okay, it has to be free. So you can have a molten ionic substance in order for it to conduct electricity, because then you will have freely moving charges.